Hello everyone. This is our YouTube channel, Abhiram's Maths Marathon. For our new viewers, just I am telling you, it started uploading videos from NCERT syllabus, solving NCERT exercises. Even I have done KCT previous year questions of differentiation chapter from 1984 till 2025. Synopsis I've done of limits chapter, and also I've done PYQs of JEE Main from 2019 to 2025 limits chapter, and also I've been doing even other topics of JEE Main like definite integration, trigonometry, inverse trigonometry, application of derivatives. I have covered various other topics. Okay, I'll be uploading more and more videos in the coming days. Okay, even NDA also I have done one yesterday. NDA's video has been uploaded. It is a 7 hours video. Okay, I solved all 120 questions of NDA 2025 April shift paper. Okay, NDA exams are coming shortly, correct? NDA 2 is coming on September 14th, this Sunday, coming Sunday. NDA exams are there, so preparation has to be there for all students who are writing the exams, for them to get confidence on the writing examination. I've done the NDA 2025 of April shift. I'll be uploading more and more videos. I'll be doing videos connected to even NDA papers also of the previous year questions and CET, even synopsis of all the chapters, even NCERT syllabus of both first PU and second PU. Exercise wise, I'll be solving all the problems along with the concepts. Okay, so this is about our channel. Okay, even JEE means also all the PMICs will be covered from 2025 going back till 2019. Okay, 2019 to 25, all the shifts papers will be covered chapter wise. Okay, because from 2019 onwards, NTA has been conducting the examination. So NTA is also conducting the exam for 2026. So we need to know how the questions and what level of questions will be asked. So you'll get exposed to variety of questions in listening to those classes. So it's very beneficial to subscribe to my channel and listen to the videos. I'll be imparting more and more knowledge also, and you'll get skills and techniques also. And also one more course I'm going to do is I'm going to build you the gap between constructing the gap between NCERT and JEE. Even some topics that is also required, because NCERT syllabus, no, all the questions are very easy, correct? JEE means the questions are a little bit depth, correct? So difficult questions are asked in JEE Main. So if you bridge the gap between NCERT and JEE, then JEE part becomes easy. So I'm going to do such kind of topics also, where the bridging the gap between NCERT and JEE is required. Those also I'm going to do. Okay, so several videos will be uploaded in the coming days. I have plan of uploading nearly 800 videos in next 1 year. Okay, please subscribe to my channel. With this, in this session I'll be doing NCERT exercise 5.7 second order derivatives, that is a differentiation chapter. Second order derivative is also called as successive differentiation. You're differentiating it 2 times. Given a function y is equal to f of x, you differentiate y dy by dx, we get. If f of x is differentiable, we get dy by dx equal to f dash of x. If f dash of x is differentiable, again you differentiate, finding the derivative of the first derivative is called as second order derivative. So second order derivative I'm going to discuss. I'll be solving all the problems of NCERT exercise 5.7. Okay, there are many 5-mark questions from this topic. Okay, it's quite important for board examinations, and also how it's important for competitive exams also. I'll tell you in what way they can ask questions. Even that also you should learn. That's more important. So we'll begin NCERT exercise 5.7 second order derivatives. What I told just now, given a function y equal to f of x, you differentiate with respect to x, you get dy by dx equal to f dash of x. If f dash of x is differentiable, again you differentiate, and dy by dx derivative is d square y by dx square. Derivative of dy by dx is d square y by dx square. Okay, that is called second order derivative, and second order derivative is denoted by various symbols. It can be denoted by y2 or y double dash or f double dash of x or d square y by dx square. Various notations used for second order derivative, you must know. Okay, so with this brief introduction of second order derivative, I can work out the problems. I have divided this second order derivatives of 4 types. One is for explicit form. Explicit form means y equal to f of x. If y is present on one side, x on other side, it's called as explicit form. And implicit form is there. Implicit form is x and y are mixed up. So that is a type 2 I have taken. And formation of differential equation. For example, there is some standard questions are there. Y equal to 3 cos log x plus 4 sin of log x. Then we have x square into y2 plus xy1 plus y equal to 0. Correct? That's a formation of differential equation we call. Y equal to tan inverse x the whole square is a very familiar question. X square plus 1 the whole square into y2 plus 2x into x square plus 1 into y1 equal to 2. All these things are called as formation of differential equation. Differential equation we are going to study in detail in the separate chapter. We have the chapter differential equations. Now we are going to form the differential equation. We are proving the second order derivatives. That answer what we get is called as a differential equation. Correct? So suppose I give y is equal to a into e power mx plus b into e power nx. Then we have d square y by dx square minus m plus n into dy by dx plus m and y equal to 0. If y is equal to a into e power mx plus b into e power minus mx, then we have d square y by dx square equal to m square y. If y is equal to a cos mx plus b sin mx, then we have d square y by dx square plus m square y equal to 0. All those things you must know. A cos mx plus b sin mx. Correct? So all these things are called formation of differential equation. That is type 3 I have taken. And type 4 is parametric form. They give x as a function of t, y as a function of t, or x as a function of theta, y as a function of theta. Then in that case you find out dy by dx by parametric form. In that case you find the second order derivative d square y by dx square. There is only one question of that type in NCERT exercise. Even in the NCERT exam book also you can find that kind of question. Okay. So I have done NCERT miscellaneous exercise separately, and this is 5.7 exercise. Okay, I have taken the problems connected to NCERT exercise 5.7, also the solved examples of that exercise. Okay, from the NCERT book. So we're going to discuss the first one, type 1 explicit form. Find the second order derivatives of the following functions. These are the questions here. So you need to find the second order derivative for all these things. Take the given function as y and find out dy by dx. Again differentiate dy by dx, again d square y by dx square. Differentiating the first derivative, or you get the second derivative. If you differentiate the second derivative, you get the third derivative. If you differentiate the third derivative, you get the fourth derivative. Like that you can go on finding nth derivative. If you go to engineering, no, you're going to study nth derivative of a function. Nth derivative of function can be studied in case of first semester of engineering mathematics, M1 they call. Okay. Now we should find out this to understand how to find the second order derivatives. Okay. Given a function y equal to like this. These are all explicit forms. Okay. So I'll call this function as y and differentiate 2 times. Okay. To find the second order derivative. So we'll begin the first one. Y is equal to, let y be equal to x square plus 3x plus 2. Differentiate with respect to x. I'm going to get dy by dx. Dy by dx equal to derivative of x square. It's a polynomial of degree 2. It's a quadratic polynomial. Very familiar expression. Correct? Derivative of x square is 2x. And derivative of 3x is 3. 3 into 1, 3. Derivative of 2 is 0. Constant into variable, how to differentiate? Constant keep as it is, differentiate x with respect to x1. Correct? Derivative of x square is 2x. Derivative of 3x is 3 into 1, 3. Derivative of 2 is 0. Correct? So what I am getting is derivative dy by dx is 2x plus 3. Again you differentiate this. Again differentiate with respect to x. I am going to get d square y by dx square. Derivative of 2x is 2. Correct? 2 into 1. Constant into variable. How to differentiate? Constant you write as it is. Differentiate x with respect to x1. And derivative of 3 is 0. So 2 into 1. 2 is the answer. d square y by dx square is equal to 2 I am getting. Second order derivative is 2. Now, we go to the second one. Y equal to x power 20. Correct? Second question. Given y equal to x power 20. Take the given function as y. Let y be equal to this x power 20. Let y be equal to x power 20. Differentiate with respect to x. I won't write the sentence here. Just tell orally. Derivative of y with respect to x dy by dx. Derivative of x power 20 is how much? 20 into x power 19. Using derivative of x power n formula. Derivative of x power n is n into x power n minus 1. Derivative of x power 20 is 20 into x power 20 minus 1. Again differentiate this. Differentiating the first derivative, what we get is second derivative. So d square y by dx square. D square y by dx square. Again you differentiate. Constant into variable. Constant you write as it is. Constant keep as it is. Differentiate x power 19. Derivative of x power 19 is 19 into x power 18. Correct? 20 into 19 becomes 380. 380 into x power 18. 20 into 19 is 380. 380 x power 18. On to the next one. Question number 3. Take the given function as y. Take y is equal to x cos x. Differentiate by using product rule. Again differentiate dy by dx. You get d square y by dx square. Also note that d square y by dx square means d by dx of dy by dx. One more thing I should tell you is d square y by dx square is what meaning? It is differentiating the first derivative with respect to x. Okay? d by dx of dy by dx. d by dx of dy by dx is called as d square y by dx square. Differentiating the first derivative with respect to x is called as second order derivative. So don't think that I'm multiplying and getting the answer. Don't, some students misunderstand like this. D into d, d square y, d into d, d square x square. Don't ask why I'm not writing d square x square. The d square y by dx square is the notation used for second derivative and it's not multiplying and getting there. Hope you understand. So similarly, I can write d cube y by dx cube. What is the meaning of d cube y by dx cube? D cube y by dx cube means you're differentiating the second derivative with respect to x. D by dx of d square y by dx square. This is the notation for third order derivative. D cube y by dx cube. And the meaning of the third order derivative is you're differentiating the second derivative with respect to x. Second order derivative means you're differentiating the first derivative with respect to x. D square y by dx square means d by dx of dy by dx. You're differentiating dy by dx with respect to x. Get the d square y by dx square, second order derivative. Hope you understand what is the meaning of second order derivative, what is the meaning of third order derivative. All those things is a very basic knowledge. Okay, now we shall find out. Next question. Move on to the next one. Take the given function as y. Third one I'm going to do here. Let y be equal to x cos x. Let y be equal to x into cos x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What do you get? dy by dx. dy by dx. Here you apply the product rule. Apply product rule because it is the product of two functions. First function keep as it is. Differentiate the second function. Plus second function keep as it is. Differentiate the first function. Applying the product rule. First function you write as it is. Derivative of cos x minus sin x. Plus second function keep as it is. Differentiate x, that is 1. Correct? First function keep as it is. Differentiate the second function. Derivative of cos x minus sin x. Plus second function keep as it is. Differentiate x with respect to x1. So dy by dx I'm going to get like this. dy by dx is minus x sin x plus cos x. Minus x sin x plus cos x. Hope you understand. First function keep as it is. Differentiate cos x with respect to x minus sin x. Plus second function keep as it is. Differentiate x with respect to x1. So dy by dx I got like this. Differentiate with respect to x again. Differentiate with respect to x again. What do you get? D square y by dx square. D square y by dx square is equal to minus of minus sin keep outside. Here you apply the product rule x into sin x. To differentiate x into sin x, apply the product rule x into derivative of sin x cos x plus sin x into derivative of x1 minus sin keep outside. Apply the product rule. First function keep as it is. Derivative of sin x is cos x plus sin x into derivative of x is 1 minus sin is kept outside. First function keep as it is. Derivative of sin x cos x with respect to x I'm differentiating plus second function write as it is. Differentiate x with respect to x1 and derivative of cos x is minus sin x. Derivative of cos x into 1 cos x. Derivative cos x minus sin x. Open this bracket and simplify one more step. minus x cos x, minus x cos x, minus into plus, minus sin x, minus sin x, minus sin x becomes minus 2 sin x. Correct? Minus sign kept out. Derivative of x sin x, x into cos x plus sin x into 1. And derivative of cos x minus sin x. Open the bracket and write minus x cos x, minus into plus minus sin x, minus sin x minus sin x, minus 2 sin x. Third one is over. Next go to the fourth one. Take the given function as y. Let y be equal to x log, y equal to log x. Correct? Let y be equal to log x. Let y be equal to log x. Differentiate with respect to x. What we get? dy by dx. dy by dx. Derivative of log x. 1 by x. Again differentiate this. d square y by dx square. Derivative of 1 by x is minus 1 by x square. Derivative of log x 1 by x. Again differentiate. If you differentiate dy by dx, we get d square y by dx square. Derivative of 1 by x is minus 1 by x square. So second order derivative for log x is minus 1 by x square. Move on to the next one, fifth one. Take this function as y, x cube into log x. Let y be equal to x cube into log x. Let y be equal to x cube into log x. Let y be equal to x cube into log x. Differentiate with respect to x. What I get? dy by dx. Apply the product rule. First function you write as it is. Differentiate the second function. Plus second function write as it is. Differentiate the first function. First function write as it is. X cube into derivative of log x 1 by x. Correct? Plus second function log x keep as it is. Differentiate x cube, that is 3x square. Correct? First into derivative of second plus second into derivative of first. First function you write as it is. Derivative of log x 1 by x plus second function you keep as it is. Derivative of x cube is 3x square. Okay? Applying product rule. So that here see 1x will cancel. So this becomes x square plus, first I'll write the constant term here, 3 into x square into log x. dy by dx I got like this. Correct? First into derivative of second. First function write as it is. Derivative of log x 1 by x plus second function write as it is. Derivative of x cube 3x square. 1x will cancel. So I get x square plus 3x square log x. Differentiate this with respect to x again on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x again. Differentiate with respect to x again on both sides. What do you get? When you differentiate dy by dx, I am getting d square y by dx square. D square y by dx square. Derivative of x square is 2x. Derivative of x square is 2x. Here I need to apply the product rule. 3 you keep outside the bracket. 3 you keep outside the bracket. To differentiate x square into log x, apply product rule. First function keep as it is. Derivative of log x 1 by x plus log x into derivative of x square 2x. Correct? First function keep as it is. Derivative of log x 1 by x. Correct? Plus log x into derivative of x square, that is 2x. Correct? First function write as it is. Derivative of log x 1 by x plus log x into derivative of x cube 3x square. 1x got cancelled. So x square plus 3x square log x. Differentiate with respect to x again. Derivative of x square is 2x plus constant keep outside 3. Here differentiate x square log x. First function keep as it is. Derivative of log x 1 by x plus log x into derivative of x square is 2x. Hope it's clear. Constant into variable. Constant keep as it is. To differentiate x square log x, I am applying the product rule. X square into first function write as it is. Derivative of log x 1 by x plus log x into derivative of x square is 2x. 1x will cancel here. So what you get is 2x plus 3 into here 1x will cancel. This becomes x plus 2x into log x. Correct? 1x got cancelled. Here I wrote 2 first, 2x log x. 3 into x is 3x. 3x plus 2x is 5x, correct? If you want to write one more step, 2x plus 3x plus 2 into 3 multiply 6x log x. We can add the like terms. Like terms can be added. 2x plus 3x is 5x. 5x plus 6x into log x. That's the answer. Hope it's clear. 1x got cancelled. Multiply inside. 3x plus 2x, 5x. 2 into 3, 6x log x. Fifth one is over. Sixth one you take. Take this given function as y. Let y be equal to e power x into sine 5x. Let y be equal to e power x into sine 5x. Let y be equal to e power x into sine 5x. Here you apply the product rule, correct? Question, e power x into sine 5x. Differentiate with respect to x. We get dy by dx. Apply the product rule here. dy by dx equal to dy by dx. dy by dx equal to, first function write as it is. Derivative of sine 5x is cos 5x into derivative of 5x, that is 5, plus second function keep as it is into derivative of e power x is e power x. Correct? First function keep as it is. Differentiate the second function. Derivative of sine 5x cos 5x into derivative of 5x 5, plus second function keep as it is. Derivative of e power x is e power x. Correct? Again you differentiate this with respect to x to find the second order derivative, d square y by dx square. No? So I differentiate this again. Here I should apply the product rule. Here also I should apply the product rule. Product rule for this, product rule for this. Then add the like terms and keep. Okay. 5 is constant, you can keep outside. D square y by dx square I am finding from this. This implies d square y by dx square is equal to 5 you keep outside. 5 you keep outside. Okay. This constant into variable. Constant keep outside. Differentiate this by using product rule. First function keep as it is. Derivative of cos 5x minus sin 5x into derivative of 5x is 5, plus second function keep as it is. Derivative of e power x is e power x. Correct? Constant 5 is kept outside. First function keep as it is. Derivative of cos 5x minus sin 5x into derivative of 5x is 5, plus second function keep as it is. Cos 5x into derivative of e power x, e power x. Here also apply the product rule. First function keep as it is. Sin 5x into derivative of e power x is e power x, plus e power x into derivative of sin 5x is cos 5x into derivative of 5x is 5. Understood? Constant kept outside. From the beginning I'll explain once again. First function keep as it is, e power x. Derivative of sin is cos. Derivative of sin 5x, cos 5x into derivative of 5x 5, plus second function keep as it is, sin 5x into derivative of e power x, e power x. Correct? Constant 5 keep outside. Here apply product rule. First function keep as it is, e power x. First function write as it is. Derivative of cos 5x minus sin 5x into derivative of 5x 5, plus second function keep as it is. Derivative of e power x, e power x. Again apply product rule here. First function keep as it is. Derivative of e power x, e power x, plus second function keep as it is, e power x. Derivative of sin 5x, cos 5x into derivative of 5x is 5. So multiply this and simplify. This is 5 into 5, 25. So minus 25 e power x into sin 5x. Correct? Plus 5 into e power x cos 5x. 5 into e power x cos 5x. Here plus e power x sin 5x. Plus 5 e power x cos 5x. So add the like terms. These two are like terms, can be added. Minus 25 e power x sin 5x plus e power x sin 5x minus 25 plus 1 is minus 24, correct? This is minus 24 e power x into sine 5x, and 5 plus 5 is 10, correct? These two are like terms. 10 e power x cos 5x. If you want, you can take 2 common between these two, correct? If you want, you can take 2 e power x common. So what remains is minus 12 sine 5x plus 5 cos 5x. And they can ask the maximum value of this function. I mean, maximum value of a cos x plus b sin x. That form it takes, correct? In CET exam, they can ask these kind of questions. See, suppose I take minus 2 e power x common, 2 e power x common. What remains is minus 12 sine 5x plus 5 cos 5x, correct? They can give a function like this. They can give a function like this, y equal to e power x sine 5x, and find out the second derivative and give the answer like this. D square y by dx square is equal to 2 e power x into f of x. Find maximum value of f of x, they can ask. Maximum value of a sin x plus b cos x, root of a square plus b square. Such kind of mixing type questions can be asked, even CET exams. Because this expression is quite important, correct? And 12 and 5 forms a Pythagorean triplet with 13. 12 square plus 5 square is 13 square, correct? So root of a square plus b square, if we calculate, a is minus 12 and b is 5. Root of 144 plus 25, that is 144 plus 25 is 169. Root 169 is 13. So maximum value of this function is 13. Terms inside the bracket I'm telling, f of x. So they can ask a question, given y is equal to e power x sin 5x, d square y by dx square is equal to 2 e power x into f of x. Find maximum value of f of x. They can ask. They can frame a question like this. Okay. So very nice question. Move on to the next one. 6th one is over. 7th one I should do. E power 6x into cos 3x. E power 6x into cos 3x. Take the function as y. Let y be equal to e power 6x into cos 3x. Take the given function as y. E power 6x into cos 3x. Let y equal to e power 6x into cos 3x. Correct? This was the question. Take the given function as y. E power 6x into cos 6x. Question number 7 I am doing. Correct? Differentiate with respect to x. What do you get? dy by dx. Apply the product rule. First into derivative of second, plus second into derivative of first. First function write as it is, e power 6x. Derivative of cos 3x is minus 3 sin 3x. Directly I wrote. Minus sin 3x, correct? Derivative of cos is minus sin. Minus sin 3x into derivative of 3x is 3. So I write directly minus 3 sin 3x. Plus second function cos 3x into derivative of e power 6x is e power 6x into 6, correct? 6 e power 6x. Derivative of e power x is e power x. E power 6x derivative is e power 6x into derivative of 6x, that is 6. First function write as it is. Differentiate the second function. Plus second function keep as it is. Differentiate the first function. Again I should apply d by dx, that is differentiate this further to get the second order derivative. I should apply product rule for this. I should apply product rule for this, correct? D square y by dx square I want. D square y by dx square. Differentiate with respect to x again. Here minus 3 is constant. Minus 3 keep outside. Minus 3 is constant. Keep outside the bracket. Here differentiate by using product rule. First into derivative of second. Plus second into derivative of first. Correct? E power 6x. First function keep as it is. Derivative of sin 3x. 3 times cos 3x. Correct? Cos 3x into derivative of 3x. 3. Plus second function. Sin 3x keep as it is. And derivative of e power 6x. E power 6x into 6. That is 6 into e power 6x. Plus come into this part. Hope you understand. Minus 3 is kept outside. First function keep as it is. Derivative of sin 3x, 3 cos 3x, cos 3x into 3 plus second function keep as it is. Derivative of e power 6x, e power 6x into 6. Here 6 you keep outside. Constant 6 keep outside. Here you apply the product rule. First function keep as it is. E power 6x. Derivative of cos 3x. Derivative of cos is minus sin 3x into 3. So minus 3 sin 3x, right? Minus 3 sin 3x plus second function cos 3x into derivative of e power 6x is e power 6x into 6. Correct? This 6 is kept outside, applying product rule for this. Here also minus 3 is kept outside, applying product rule for e power 6x into sin 3x. Correct? First function keep as it is, e power 6x taken as first function. Derivative of cos 3x minus 3 sin 3x plus second function keep as it is, derivative of e power 6x into 6. So what I am getting here, multiply this, minus 3 into 3 becomes minus 9 e power 6x into cos 3x. Correct? Minus 3 into 3, minus 9, minus 3 into 6, minus 18, minus 18 e power 6x into sin 3x. Minus 6 into 3, minus 18 e power 6x into sin 3x. Here 6 into 6 becomes 36 e power 6x into cos 3x. Correct? Multiply all the terms inside. Minus 3 into 3 is minus 9. Minus 3 into 6 minus 18. Minus 6 into 3 minus 18. Correct? 6 into 6 36. Correct? So adding the like terms, what we get? Minus 9 e power 6x cos 3x and this term with this. These two are like terms. Correct? E power 6x cos 3x, e power 6x cos 3x, 36 minus 9, that is 27. 27 e power 6x into cos 3x. Minus 18 is minus 36 e power 6x into sin 3x. If you want, you can take common here. 9 3s are 9 4s are. You can take 9 e power 6x common. So terms inside the bracket is 3 cos 3x minus 4 sin 3x. Here also they can ask to find the second order derivative and they give the answer like this in this form. 9 e power 6x into f of x. They can ask maximum value of this function. Maximum value of a cos x plus b sin x root of a square plus b square, or minimum value of a cos x plus b sin x they can ask minus root of a square plus b square. That also they can ask. Okay. So, and also they can ask to find the second order derivative for this at x equal to pi or 3 pi by 2 or at x equal to pi, like that. Already asked this type of question earlier. 2 times they've asked finding the second order derivative for this kind of function at x equal to some particular value. So at x equal to pi by 2 or at x equal to pi, such kind of questions are asked. Okay. Is it clear? First function keep as it is. Derivative of cos 3x minus 3 sin 3x plus second function keep as it is. Derivative of e power 6x into 6. Minus 3 kept outside. Apply product rule. First into derivative of second plus second into derivative of first. 6 you keep outside. Apply product rule. First function keep as it is. Derivative of cos 3x minus 3 sin 3x plus second function keep as it is. Derivative of e power 6x into 6. Question number 7 was over. Question number 8. Y equal to, take the given function as y equal to tan inverse x. Y equal to tan inverse x. Question number 8. Let y be equal to tan inverse x. Differentiate with respect to x. Find dy by dx. Dy by dx is derivative of tan inverse x is 1 by 1 plus x square, correct? Derivative of tan inverse x, 1 by 1 plus x square. Again differentiate this. If you differentiate dy by dx, I am getting d square y by dx square. D square y by dx square is equal to d square y by dx square is equal to. Differentiate this as you differentiate 1 by x. Derivative of 1 by x is minus 1 by x square. Derivative of 1 by 1 plus x square is minus 1 by 1 plus x square the whole square. Further differentiate terms inside the bracket. Further differentiate this 1 plus x square, that is 2x. Correct? Differentiate this as you differentiate 1 by x. Differentiate as you differentiate 1 by x. Derivative of 1 by x is minus 1 by x square. Minus 1 by 1 plus x square the whole square into derivative of 1 plus x square is 2x. Hope I understand. Derivative of tan inverse x, direct formula. Directly differentiate 1 by 1 plus x square using direct formula. To differentiate 1 by 1 plus x square, differentiate as you differentiate 1 by x. Derivative of 1 by x is minus 1 by x square. Minus 1 by 1 plus x square the whole square into derivative of 1 plus x square is 2x. Next one, question number 9, log of log x. This question was asked in CET exam to find the second order derivative in 2017. Same question. NCERT question is asked in 2017 KCET. Okay. Log of log x. Y equal to log of log x. Question number 9. Let y equal to log of log x. Log of log x. Now derivative of log x is 1 by x. So derivative of log x 1 by log x into derivative of log x 1 by x. Correct? Differentiate. Differentiate with respect to x. So I am getting dy by dx. Dy by dx is 1 by log x into further differentiate log x with respect to x 1 by x. By chain rule it follows. Correct? Derivative of log is 1 by. So 1 by log x into derivative of log x 1 by x. So dy by dx is 1 by x log x. Dy by dx is 1 by x log x. So d square y by dx square. D square y by dx square is equal to derivative of 1 by x. Derivative of 1 by x is minus 1 by x square. Correct? Differentiate as you differentiate 1 by x. Here also we use the same concept. Derivative of 1 by x is minus 1 by this entire thing square. But this is not x. So further differentiate 1 plus x square, which is 2x. Here also differentiate. Derivative of 1 by x is minus 1 by x square. So derivative of 1 by x log x is minus 1 by x log x the whole square. X log x the whole square into derivative of x log x. Differentiate as you differentiate 1 by this entire thing, you take it as x. Keep it in mind that x log x is your x. Derivative of 1 by x is minus 1 by x square. Minus 1 by this entire thing square. But this is not x. No, further differentiate x log x into d by dx of log x by chain rule. Further you should differentiate x log x. That is equal to what? Minus 1 by x log x the whole square. That you write as it is. Correct? Already that part is over. To differentiate x log x, apply the product rule. X into derivative of log x 1 by x plus log x into derivative of x is 1. Correct? To differentiate x log x, apply the product rule. First function, write as it is. Derivative of log x 1 by x plus log x into derivative of x is 1. So 1 x will cancel. So I'll get the answer as minus 1 by x log x the whole square into x cancels. What we get is 1 plus log x. So minus of 1 plus log x by x log x the whole square. Hope it's clear. Question number 9th is over. 10th one, sine of log x. Sine of log x. Let y be equal to sine of log x. Take the given function as y. Y is equal to sine of log x. Differentiate with respect to x. dy by dx. Derivative of sine of log x is cos of log x into derivative of log x, which is 1 by x. Derivative of sine is cos. cos of log x into derivative of log x 1 by x. To differentiate this now, take cos of log x as first function, 1 by x as second function. Apply product rule here for this. Again differentiate. Cos of log x into 1 by x. Differentiate with respect to x. D square y by dx square. D square y by dx square. First function keep as it is. Cos of log x into derivative of log x. Derivative of log x is cos of log x keep as it is. First function keep as it is. Derivative of 1 by x minus 1 by x square. First function you write as it is. Differentiate 1 by x, that is minus 1 by x square. Plus second function keep as it is. Differentiate the first function. Derivative of cos of log x minus sine of log x into derivative of log x 1 by x. Correct? Minus sine of log x into further differentiate log x. Derivative of log x is 1 by x. Correct? So you can take minus 1 by x square common here. Correct? Derivative of sine of log x. Derivative of sine is cos. Cos of log x into derivative of log x 1 by x. Okay? Apply product rule now at this stage. To find the second order derivative, I am applying product rule. First function keep as it is. Cos of log x into derivative of 1 by x is minus 1 by x square. Plus second function keep as it is. Derivative of cos of log x minus sine of log x into derivative of log x 1 by x. So 1 by x into 1 by x is 1 by x square. Take minus 1 by x square common. Take minus 1 by x square common. Minus 1 by x square common. What remains is cos of log x plus sine of log x. Minus 1 by x square is taken out. Cos of log x plus sine of log x. Correct? 1 by x into 1 by x, 1 by x square. Minus 1 by x square taken out. What remains inside the bracket is cos of log x plus sine of log x. That was question number 10. I think one more question is left out. That is question number 11. Y equal to x cube plus tan x. X cube plus tan x. Question number 11. Let y equal to x cube plus tan x. Whatever given, no, take the given function as y. Differentiate with respect to x. dy by dx. Derivative of x cube 3x square. Derivative of tan x is secant square x. Correct? Derivative of x cube 3x square. Derivative of tan x secant square x. Again differentiate. Further differentiate this with respect to x. We get the second order derivative. D square y by dx square. Constant into variable. Constant keep as it is. Constant write as it is. Derivative of x square with respect to x is 2x. Here derivative of secant square x. Secant square x means secant x the whole square. Differentiate as differentiate x square. Derivative of x square is 2x. So derivative of secant square x is 2 secant x into derivative of secant x, which is secant x tan x. Correct? By using chain rule. Differentiate as differentiate x square. Derivative of x square is 2x. 2 secant x into derivative of secant x tan x. So what we get is 6x plus 2 into secant x becomes secant square x into tan x. Correct? Differentiate as differentiate x square. Derivative of x square is 2x. Derivative of secant square x is 2 secant x into further differentiate secant x, which is secant x tan x. So 2 secant square x. When I multiply these two, it becomes secant square x into tan x. 3 into 2x, 6x. 6x plus 2 secant square x into tan x. So with this, all the questions of this exercise, that is question 11 questions were present. No, all the questions I've solved. Question number 1, 2, 3 is here. 1, 2, 3 is found here. Next page I've done 4. Oh, sorry, 4 is 4 I've done here, correct? This is 3, 4 is here, correct? 1, 2, 3 and 4 are done here, okay? 5th one is here, 5th, 6th is here, 7th is here, then 8, 9, 10 is done, then the 11th one is done here, okay? On to the next one, This is type 2, implicit form. Implicit form means x and y are mixed up. Can be present on the same side of the equation. So one such question is found in the NCERT book actually. I have taken few extra questions of this type, okay. So we shall work out all those things. E power y into x plus 1 equal to 1. Show that d square y by dx square equal to dy by dx whole square. Second derivative is equal to square of the first derivative. We need to show this. Second derivative. D square y by dx square is second order derivative. Dy by dx is first derivative. Square of the first derivative is equal to second derivative. So given equation I can write it as given e power y into x plus 1 equal to 1, right? Given according to the question. E power y into x plus 1 is equal to 1. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What we get? Here we shall apply the product rule. First function keep as it is. Derivative of x plus 1. Derivative of x1. Derivative of 1 0. Correct? Differentiate this bracket. Derivative of x plus 1. Derivative of x with respect to x1. Derivative of 1 is 0. 1 plus 0 is 1. Plus second function keep as it is. Differentiate the first function. Derivative of e power y is e power y into derivative of y with respect to x. dy by dx. And derivative of 1 is 0. Derivative of 1 is 0. You can take e power y common here. E power y is common. So what remains? 1 plus x plus 1 into dy by dx. E power y can't be equal to 0. Exponential function is never equal to 0. Correct? Here I am applying the product rule. First function keep as it is. Derivative of x plus 1 is 1. Plus second function keep as it is. Derivative of e power y is e power y into dy by dx. And derivative of 1 is 0. E power y is not equal to 0. We know that. Exponential function can't be equal to 0. As e power y is not equal to 0 for all y belongs to R, what I can conclude? A into B equal to 0. Product of two numbers equal to 0 means either the first number is 0 or the second number is 0. Correct? Or both of them can be 0. Since this exponential function never becomes 0, for any y belonging to R, set of real numbers, terms inside the bracket should be equal to 0. So what I can write is 1 plus x plus 1 dy by dx equal to 0. 1 plus x plus 1 into dy by dx equal to 0. So this gives x plus 1 into dy by dx equal to minus 1. X plus 1 into dy by dx equal to minus 1. Plus 1 take that, so it becomes minus 1. Therefore, dy by dx equal to minus 1 by x plus 1. dy by dx is minus 1 by x plus 1. Correct? Getting like this. 1 plus x plus 1 dy by dx. Terms inside the bracket should be equal to 0 as exponential function never becomes 0. Correct? Exponential function range is all positive real numbers only. Correct? Can't become 0, can't be negative. Range of exponential function is open interval 0 to infinity. So 1 plus x plus 1 dy by dx should be 0. X plus 1 dy by dx equal to minus 1. So dy by dx is minus 1 by x plus 1. Differentiate this with respect to x again. And also I'll do squaring on both sides because I want dy by dx the whole square. Correct? Dy by dx the whole square I want. Also I want second order derivative. This will call equation 1. Equation 1. Differentiate equation 1 with respect to x again. Differentiate equation 1 with respect to x. Differentiate equation 1 with respect to x. What we get? When you differentiate dy by dx, I get d square y by dx square. And we know derivative of 1 by x is minus 1 by x square. Derivative of 1 by x plus 1 is minus 1 by x plus 1 the whole square. Already there is minus sign. Minus sign keep as it is. Derivative of 1 by x plus 1 is minus 1 by x plus 1 the whole square. Minus 1 divided by x plus 1 the whole square into derivative of x plus 1 is again, that is 1. Correct? Minus you keep as it is. Differentiate 1 by x plus 1. Derivative of 1 by x plus 1 is minus 1 by x plus 1 the whole square into derivative of x plus 1 is 1. So minus of minus becomes plus. This is 1 by x plus 1 the whole square. 1 by x plus 1 the whole square. D square y by dx square we got. Correct? This is equation 2. Equation 2. Squaring equation 1. Squaring equation 1. If you do squaring of equation 1, what we get? What we get? Squaring this equation 1. Equation 1 you do squaring on both sides. Dy by dx the whole square you get. Dy by dx the whole square, correct, is equal to minus 1 square is plus 1 divided by x plus 1 the whole square. This we call equation 3. So compare this two. This is d square y by dx square. This is dy by dx the whole square. So dy by dx the whole square is squaring this equation. So compare equations 2 and 3. So from 2 and 3, see right hand side is same. 1 by x plus 1 the whole square. 1 by x plus 1 the whole square. If right hand side is same, I can conclude that left hand side should be same. From equations 2 and 3, we can conclude that d square y by dx square equal to dy by dx the whole square. Correct? Therefore, I'll write the conclusion here. From equations 2 and 3. From equations 2 and 3, we get d square y by dx square is equal to dy by dx the whole square. D square y by dx square is equal to dy by dx the whole square. Is that clear? Move on to the next one. Y square is equal to 4x. Prove that d square y by dx square equal to minus 4a square by y cube. This is the equation of parabola having vertex at origin. Correct? It is symmetric with respect to x-axis. Vertex at origin and it is symmetric with respect to x-axis. If a is positive, it is right-handed parabola. Correct? So this is a extra question I've taken, not there in the NCERT book exactly. I've taken additional questions for second time, implicit form. Okay. So I'll rewrite this equation, or you can differentiate this directly also. Given y square is equal to 4ax. Given y square is equal to 4x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of y square is 2y into dy by dx. Derivative of y square is 2y dy by dx. Constant into variable. Constant keep as it is. Differentiate x with respect to x1. 4a into 1. Correct? 4a. Derivative of y square is 2y dy by dx by using chain rule. Derivative of x square is 2x. Derivative of y square 2y into derivative of y with respect to x dy by dx. Constant into variable, constant keep as it is. Derivative of x with respect to x1. So dy by dx is, can write this as 2a by y, correct? Dy by dx. You can cancel 2 1s are 2 2s are. So this is 2a and y is brought to denominator. So 2a divided by y, dy by dx. 2a is a constant. I can write 2a by y as 2a into 1 by y. So that it takes the form constant into variable. Constant into variable form. Differentiate this with respect to x again. Differentiate with respect to x again. Differentiate with respect to x again on both sides. What do you get? Dy by dx, if you differentiate, you get d square y by dx square. Here, constant into variable. Constant keep as it is. Derivative of 1 by y is minus 1 by y square into dy by dx. Further, you should differentiate y with respect to x, correct? Derivative of 1 by x is minus 1 by x square. Derivative of 1 by y. Derivative of 1 by y is minus 1 by y square into derivative of y with respect to x dy by dx. So what I am getting is minus 2a divided by y square into dy by dx we got in the previous step. Now 2a by y. I'll substitute this. dy by dx, how much we got? 2a divided by y. From the previous step, I'm substituting the value of dy by dx. So this becomes minus 4a square divided by y cube. 2a into 2 is 4a square by y cube minus 4a square by y cube. Hope it's clear. On to the next one. X square plus y square is equal to 1. Show that d square y by dx square equal to minus 1 by y cube. Given x square plus y square is equal to 1. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate derivative of x square with respect to x to x. Derivative of y square with respect to x 2y dy by dx. And derivative of constant is 0. Correct? Apply differentiation for this. Derivative of x square 2x. Derivative of y square 2y dy by dx. Derivative of 1 is 0. So from this what we get? 2x is equal to minus 2y into dy by dx. 2x is equal to minus 2y dy by dx. So 1, 2 is going to cancel. Correct? 2, 2 cancels. I'm getting dy by dx is equal to minus x by y. Minus x by y. 2x is equal to minus 2y dy by dx. 2, 2 cancels. So dy by dx is minus x by y. Again differentiate this with respect to x. We get the second order derivative d square y by dx square. So for this you can apply the quotient rule. Differentiate with respect to x again. Differentiate with respect to x again. When you differentiate dy by dx, I am getting d square y by dx square. Here you apply the quotient rule, denominator square. Otherwise I'll write on the top. I'll write here. dy by dx, if you differentiate, what I'm getting? D square y by dx square is equal to. Here you apply the quotient rule, denominator square. Denominator square. Correct? Minus you keep outside. Minus you keep outside. Denominator into denominator keep as it is. Differentiate the numerator, derivative of x1 minus numerator into derivative of denominator, that is dy by dx. Correct? Applying quotient rule, u by v rule. Denominator square. In the numerator, you start from denominator, minus is kept outside. Denominator you write first, y. Differentiate x1 minus x into numerator into derivative of denominator. Derivative of y with respect to x is dy by dx. And dy by dx is substitute from this. From this is substitute. Dy by dx we call it as minus x by y. No? Substitute there. So what do you get? Minus of y minus x into dy by dx we got minus x by y. Dy by dx we got minus x by y. Dy by dx we got minus x by y. Correct? Substitute. So this is equal to minus of, what do you get? Y minus into minus plus, x into x becomes x square divided by y square. Here you take LCM, y, correct? Y is LCM. So this becomes y square plus x square divided by y square. And x square plus y square is 1 from this, from the given original equation. X square plus y square is 1. So this becomes minus 1 by y divided by y square. This y comes to denominator. So becomes minus 1 by y cube. Minus 1 by y cube. Dividing by y square means multiply by 1 by y square. So 1 by y into 1 by y square, which is 1 by y cube. So we get minus 1 by y cube. Hence rule. D square y by dx square we got. The equation of circle having center at origin and radius is 1. Move on to the next one. This is the equation of the type ax square plus 2hxy plus by square equal to k. I can use a shortcut method for this actually. I'll do it in detail because it's a very important question for CET point of view actually. It takes the form ax square plus 2hxy plus by square equal to k. In that case, d square y by dx square, there is one standard result actually. K into h square minus ab by hx plus by the whole cube. See, by CET point of view, if you compare this equation, ax square plus 2hxy plus by square is equal to k. This is the left hand side is a homogeneous function, so degree 2, correct, we call. And in this case, no, d square y by dx square is given by this formula. D square y by dx square is equal to k into h square minus ab divided by hx plus by the whole cube. Hx plus by the whole cube. So here k is 1, no? K is 1. Identify that k is 1. 1 into h is how much? 2h is 2. So h is 1, right? H is 1. 1 square. Minus ab. A is 1. B is 3. Correct? A is 1. B is 3. 1 into 3. 3. Correct? Divided by hx plus by the whole cube. H is 1. Correct? 2h is 2. So h is 1. 1 into x. X plus b is how much? B is 3. 3y the whole cube. So what do you get? 1 square 1. 1 minus 3 is minus 2. Minus 2 divided by x plus 3y the whole cube. Over. If you want to do the actual method, we are learning the differentiation, no? So we'll do the actual method. So implicit form, because x and y are mixed up. So I'm finding the second order derivative for this. Okay. So I shall erase this part. Okay. So that I need more space to do this. This is our shortcut method or time saving result we call. Okay. Whenever the equation takes the form ax square plus 2hxy plus by square equal to k, d square y by dx square is k into h square minus ab by hx plus by the whole cube. Okay. So differentiate this with respect to x, find dy by dx and find the second order derivative. Given equation is x square plus 2xy plus 3y square is equal to 1. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of x square is 2x. To differentiate 2xy, 2 is constant, keep outside. Derivative of xy is x into dy by dx plus y into 1 by using product rule. Constant, keep outside. Differentiate xy, x into dy by dx plus y into 1. Derivative of 3y square, 3 into derivative of y square is 2y dy by dx. And derivative of 1 is 0. Derivative of constant is 0. Derivative of x square 2x. Constant into variable. Constant keep outside. To differentiate xy, use product rule. X into dy by dx plus y into 1. Constant into variable. Constant keep outside. Derivative of y square is 2y dy by dx. Derivative of constant is 0. Correct? So what we get from this? 2x plus 2x into dy by dx plus 2y, correct, plus 6y into dy by dx equal to 0. We can divide the entire equation by 2. We can divide throughout by 2. 2 is a common factor. So dividing by 2, what I get? X plus x into dy by dx, correct, plus y plus 3y dy by dx. Dividing the entire equation by 2. Now take dy by dx common between these two. If you take dy by dx common, what do you get? X plus 3y. Correct? These two terms without dy by dx, you send it to that side. Minus x minus y. That is minus of x plus y. Minus of x plus y. So dy by dx is minus of x plus y divided by x plus 3y. Therefore, what I am getting? Dy by dx. Dy by dx is equal to minus of x plus y divided by x plus 3y. I'm getting like this, dy by dx. Differentiate this with respect to x again on both sides. Differentiate this with respect to x on both sides. You have to apply the quotient rule here. Differentiate with respect to x again on both sides. Okay, what do you get? D square y by dx square. D square y by dx square. Use quotient rule. Denominator square. X plus 3y the whole square. Here minus of, what do you get? Denominator keep as it is. Denominator keep as it is. Differentiate the numerator. Derivative of x plus y is derivative of x1. Derivative of y is dy by dx. Minus x plus y into derivative of denominator. Derivative of x is 1. Derivative of 3 into y, that is 3 into dy by dx. Applying quotient rule. Denominator square. Denominator square. Denominator keep as it is. Denominator keep as it is. Minus sign is kept outside, I think. Yeah, minus sign is kept outside. Okay. This minus sign is kept outside. Minus sign is kept outside. Okay. Denominator keep as it is. Differentiate the numerator. Derivative of x plus y is 1 plus dy by dx. Derivative of x1. Derivative of y is dy by dx. Minus numerator keep as it is. Differentiate denominator. Derivative of x plus y. Derivative of x is 1. Derivative of 3y is 3 into dy by dx. Now simplify this. Minus of x into 1 x plus 3y into 1 3y. Correct? X into dy by dx. X into dy by dx plus 3y dy by dx. Correct? I am multiplying all the terms. I open the bracket. X into 1 x. 3y into 1 3y. X into dy by dx. 3y into dy by dx. Minus here x into 1 x minus into y minus y into 1 minus y. Correct? Minus x into 3 dy by dx. So minus 3x dy by dx. Then minus into plus minus. Minus 3y dy by dx. Minus 3y dy by dx. Correct? Divided by, what we have is x plus 3y the whole square. So some terms are cancelling out here because of their of opposite sign. Same terms with opposite sign cancels out. Plus x minus x will cancel out. 3y dy by dx will cancel. Correct? 3y dy by dx will cancel. So what is left out? Still I can simplify the like terms. Add the like terms. 3y minus y is 2y. Correct? So this is minus of 3y minus y. That is 2y. Correct? Then what we have? X into dy by dx minus 3x into dy by dx. That is minus 2x into dy by dx. And also again I have to substitute the value of dy by dx which I got in the previous step here. Dy by dx I got here. That I am going to substitute here. Getting 2 common. And simplify it further. Denominator is here. At this stage x plus 3y the whole square. So what you get is minus 2 you keep outside. What we have is y minus x into what is dy by dx minus of x plus y by x plus 3y. Minus 2 outside. Correct? Y minus x into dy by dx. Dy by dx I am substituting. What we have dy by dx is into minus of x plus y divided by x plus 3y. Divided by x plus 3y the whole square. So minus into minus is plus. Correct? Minus into minus becomes plus. Take common denominator as x plus 3y. So I'll write here itself. D square y by dx square is equal to d square y by dx square is equal to what we have? Minus 2 into taking common denominator x plus 3y. That will come to denominator. So what I am getting is x y into x plus 3y. Y into x plus 3y. Correct? Minus into minus is plus. X into x plus y. Plus x into x plus y. Divided by, this will come to denominator, x plus 3y the whole cube it becomes. x plus 3y is taken common denominator, that comes to denominator, becomes x plus 3y the whole cube. So what we get is minus 2 into, here open the bracket, xy plus 3y square plus x square plus xy, correct, divided by x plus 3y the whole cube. And this is x square plus 2xy plus 3y square. That is what I am getting. Numerator is 1. Terms inside the bracket of numerator is 1. Using this equation, x square plus 2xy plus 3y square. Here I am getting x square plus 3y square plus 2xy. Same thing, no? So the terms inside the bracket is 1. So minus 2 into 1 divided by x plus 3y the whole cube, which is equal to minus 2 divided by x plus 3y the whole cube. That's the answer. Minus 2 divided by x plus 3y the whole cube. It's clear, no? So finding the second order derivative for implicit function. Here I have taken some 3 questions extra which is not there in the NCERT book, okay, for your better understanding, for preparing for even competitive exams too. So that becomes easy. But don't do all these big steps in the competitive exams. So time killing, okay. So you can save the time as I told you. You compare this equation with ax square plus 2hxy plus by square equal to k. Then d square y by dx square is what? K into h square minus ab divided by hx plus by the whole cube. Okay. So this is the type 2 problems. Type 3 is, one more question is there, y equal to cos inverse x. This was the 4th question, right? One more question is there, and this is from NCERT book only. Y equal to cos inverse x, find d square y by dx square in terms of y alone. So here, what I'll do is, given y equal to cos inverse x, given equation is y equal to cos inverse x. From this, we rewrite this as x equal to cos y. You want to get the answer in terms of y alone. Want to find the second derivative in terms of y alone. So from this I rewrite this as x equal to cos y. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What do we get? Derivative of x with respect to x1. Derivative of cos y is minus sin y into dy by dx, correct? Derivative of cos is minus sin y into dy by dx, because I am differentiating with respect to x. So dy by dx is minus 1 by sin y. From this, dy by dx is minus 1 by sin y. This is equal to minus 1 divided by sin y. That is equal to minus 1 by sin y is cosecant y. Dy by dx, 1 by sin is cosec. Again differentiate with respect to x. Again differentiate with respect to x. Again differentiate with respect to x on both sides. What we get? Dy by dx derivative will be d square y by dx square. Differentiate dy by dx, I am getting d square y by dx square. And derivative of cosec y is minus cosec y cot y into derivative of y with respect to x. So dy by dx again comes. Minus you keep as this. Minus you keep as this. Derivative of cosec y is minus cosec y into cot y into dy by dx. Dy by dx. Correct? Derivative of cosec y is minus cosec y cot y into further differentiate y with respect to x dy by dx. Correct? Minus into minus will become plus. So this becomes cosec y into cot y into dy by dx. We got it as minus cosec y from the previous step. That I am going to substitute. Minus into minus became plus. Another minus comes here. Dy by dx is minus cosec y. So this becomes equal to minus cosecant square y into cot y. So d square y by dx square, we got like this. Second order derivative. So we got the answer in terms of y alone. So to start with, what you do is rewrite y equal to cos inverse x as x equal to cos y. Rewrite the equation like this. X equal to cos y. Differentiate with respect to x. Derivative of x with respect to x1. Derivative of cos y minus sin y into dy by dx. So dy by dx is minus 1 by sin y, which is minus cosec y. So again differentiate with respect to x on both sides. Derivative of dy by dx is d square y by dx square. Minus sign you keep as it is. Derivative of cosec y is minus cosec y cot y into dy by dx. Minus of minus plus. And substitute back for dy by dx from the previous step. Minus cosec y. So dy by dx is minus cosec y. Minus you keep outside. Cosec y into cosec y. Cosecant square y into cot y. Hope you understand this. Is that clear? Shall we move on to the next type? I think 5 questions were given on this implicit form. Okay. Next one is the formation of differential equations. These are the important time-saving results you can take. For board exam, this will be asked for 5 marks. Most of the questions, except some of the last 2 or 3 may not be asked for 5 marks. But the first 6 questions are very important. Okay, 7, 8, 9 can be asked for 2 marks or 3 marks. Okay, not a big lengthy question. But first 6 is very important. And the first, second, third is very important question. So can be asked and will be asked for 5 marks. So already I told these results. You can remember this as a standard results for CET. So CET it's better to learn this as a result only. Okay. So if already this question, the first one is asked in KCET 2014 also. Okay. So I'll take one by one and learn this as a result. Okay. We'll take the first one, 5-mark question, very important. Okay, very important question. It's a 5-star question. This is okay. Y equal to tan inverse x the whole square. Given according to the given equation, what is given? I'm writing y equal to tan inverse x the whole square. Differentiate with respect to x on both sides. Then double differentiate. We'll get the differential equation like this. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What do you get? Derivative of y is y1 because in the question they use the derivative y1 and y2. y1 is the first order derivative, y2 is second order derivative. y1 stands for dy by dx and y2 for d square y by dx square. So same notation I shall use. What is given in the question, same thing I'll use. Y derivative is y1, correct? Derivative of y is y1. y1 means dy by dx. Differentiate this as a differentiate x square. Derivative of x square is 2x. Derivative of tan inverse x the whole square is what? 2 tan inverse x into derivative of tan inverse x 1 by 1 plus x square. Derivative of tan inverse x whole square is 2 into tan inverse x. 2 into tan inverse x into derivative of tan inverse x 1 by 1 plus x square. Differentiate as you differentiate x square. Derivative of x square is 2x. So 2 tan inverse x into further differentiate tan inverse x, which is 1 by 1 plus x square. Cross multiply this. So what do you get? From this y1 into 1 plus x square is equal to 2 tan inverse x. Correct? Cross multiply. 1 plus x square cross multiply. y1 into 1 plus x square is equal to 2 tan inverse x. Differentiate with respect to x again on both sides. Differentiate with respect to x again on both sides. Cross multiply this, taken to left hand side. Apply the product rule here. Multiplication of two functions is there on left hand side. First function keep as it is. Differentiate the second function. Plus second function keep as it is. Differentiate the first function. Correct? Applying the product rule. First function write as it is. Differentiate the second function. D by dx of 1 plus x square. Differentiating means you are applying the d by dx operator. Plus second function keep as it is. d by dx of y1, d by dx of y1 is equal to 2 into d by dx of tan inverse x, constant into variable, constant keep as it is, differentiate tan inverse x. First function keep as it is, differentiate the second function, plus second function keep as it is, differentiate the first function. Constant into variable, constant keep as it is, differentiate tan inverse x. Now I am applying d by dx for 1 plus x square. Derivative of 1, 0. Derivative of x square, 2x. So y1 into 2x plus 1 plus x square into derivative of y1 is y2. Derivative of y1 is y2. Here constant into variable, constant keep as it is, derivative of tan inverse x, 1 by 1 plus x square. This you cross multiply. Multiply the entire equation by 1 plus x square. Derivative of y1 is y2. If you differentiate the first derivative, what we get is second derivative. I hope you understand. Here I am applying the product rule because it is multiplication of two functions. First function write as it is. Differentiate the second function plus second function keep as it is. Differentiate the first function. D by dx of y1 is y2. Here constant into variable, constant keep as it is, derivative of tan inverse x, 1 by 1 plus x square. 5 mark question, this is very important, 5 marks question. So hardly 5 steps. Please practice this properly. Those are preparing for board exams. Multiply the entire equation by 1 plus x square. Okay. Multiply throughout by 1 plus x square, or you cross multiply this. What we have, that is 2x y1 is there, correct? 2x y1 plus what we have, 1 plus x square, 1 plus x square into y2. This is to be multiplied by 1 plus x square, cross multiply, okay? 1 plus x square is equal to 2, correct? So from this, what do you get? 1 plus x square into 1 plus x square. That is 1 plus x square is same as x square plus 1. So multiply this and this. I get x square plus 1 the whole square. X square plus 1 the whole square into y2 plus 2x into 1 plus x square into y1. 2x into 1 plus x square into y1 is equal to 2. Hence proved. Just cross multiply this. 1 plus x square is same as x square plus 1. X square plus 1 into x square plus 1. X square plus 1 the whole square into y2 plus 2x into 1 plus x square y1 is equal to 2. Proved. This is the answer. Correct. On to the next one. Y equal to 3 cos of log x plus 4 sin of log x. Show that x square y2 plus x y1 plus y equal to 0. This is also very important question. Please practice it. Given y is equal to 3 cos of log x plus 4 sin of log x. 3 cos of log x to the base e plus 4 sin of log x to the base e. Differentiate with respect to x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of y is y1. Here constant into variable, constant keep as it is. Derivative of cos is minus sine. Minus sine of log x into derivative of log x 1 by x by chain rule. Correct? Constant keep as it is. Derivative of cos of log x is minus sine of log x into derivative of log x is 1 by x. Correct? Constant into variable. Constant right as it is. Differentiate the variable. Derivative cos is minus sine. Minus sine of log x into derivative of log x 1 by x plus 4 into derivative of sine of log x is cos of log x into derivative of log x is 1 by x. Correct? Constant into variable. Constant keep as it is. Derivative of sine is cos. Cos of log x into derivative of log x 1 by x. You can take 1 by x common here. 1 by x is common. So if you take 1 by x common, what remains here is minus 3 sine of log x plus 4 cos of log x. Minus 3 sine of log x plus 4 cos of log x. This is y1. Cross multiply. We get x into y1. X into y1 is equal to minus 3 sine of log x plus 4 cos of log x. Correct? After cross multiplying, I am getting like this. At this stage, we can differentiate this with respect to x again. Differentiate with respect to x again on both sides. Differentiate with respect to x on both sides. Again, I am differentiating. So left hand side, I need to apply the product rule. X into y1. It's multiplication of two functions. X into y1. X is first function, y1 is second function. Apply product rule or UV rule. First into derivative of second plus second into derivative of first. Correct? First function keep as this. X. Derivative of y1 is y2 plus y1 into derivative of x is 1. Correct? Apply the product rule. First function keep as this. Derivative of y1 is y2. First function write as it is. Differentiate y1 with respect to x, that is y2, plus second function y1 keep as it is. Derivative of x is 1. Correct? First into derivative of second plus second into derivative of first. Applying product rule. X is first function, right, as it is. When you differentiate y1, we get y2. y1 means first derivative. y2 means second derivative. If you differentiate dy by dx with respect to x, what we get is second derivative, d square y by dx square. So derivative of y1 with respect to x is d square y by dx square. Derivative of y1 with respect to x, y2. Correct? First function keep as it is. Derivative of y1 is y2 plus second function keep as it is. Derivative of x, 1. First function write as it is. Differentiate y1 with respect to x, that is y2, plus second function keep as it is. Derivative of x with respect to x, 1. That's equal to minus 3 into derivative of sine of log x is cos of log x into derivative of log x, which is 1 by x. Minus 3, constant keep as it is. Derivative of sine of log x is cos of log x into derivative of log x is 1 by x. Correct? Close the bracket here. Constant into variable. Constant, write as it is. Derivative of sine is cos. Cos of log x into derivative of log x, 1 by x. Plus 4 into, again, constant into variable. Constant keep as it is. Derivative of cos of log x minus sine of log x into derivative of log x, which is 1 by x. You can take 1 by x common here. Correct? So what I am getting here is, therefore, what I am getting is x into y2 plus y1 is equal to, what is common? 1 by x is common, correct? Even minus sign is common, correct? Minus is common, 1 by x is common. So minus 1 by x to take outside. Minus 1 by x is common. So what is left out? 3 cos of log x plus 4 sine of log x. 3 cos of log x plus 4 sine of log x. 3 cos of log x plus 4 sine of log x. Multiply the entire equation by x. This x will cross multiply. X into xy2 becomes x square y2 plus x into y1 is xy1 is equal to minus 1 into terms inside the bracket is nothing but y, correct? Because y is what? 3 cos of log x plus 4 sine of log x. The base is given as e, are not written in the base. That does not matter because e is a standard base. Whether you write e or don't write it doesn't matter because e is a standard base. So 3 cos of log x plus 4 sine of log x is nothing but y from this equation, from the given equation. So what I am getting inside the bracket here is 3 cos of log x plus 4 sine of log x, that is y. So minus 5, bring this up, becomes plus y, correct? Therefore, what we get? X square into y2 plus x into y1 minus y, bring this up, becomes plus y is equal to 0. Hence we get x square y2 plus x y1 plus y equal to 0. Hence proved. Important question, 5 marks, very important. Please practice. Both the questions are very important. Y equal to tan inverse x the whole square I did here. correct? This was y equal to tan inverse x the whole square, x square plus 1 the whole square into y2 plus 2x into x square plus 1 into y1 equal to 2. Very important question. Even this is very important. Y equal to 3 cos of log x plus 4 sin of log x. Differentiate, take 1 by x common, cross multiply, again differentiate, that is double differentiate. Here apply product rule and simplify. Here 1 by x common, in fact minus 1 by x is common. What remains inside the bracket is 3 cos of log x plus 4 sin of log x. 3 cos of log x plus 4 sin of log x, that is y. 3 cos of log x plus 4 sin of log x is y. So minus y. Minus will bring the left hand, so becomes plus y. Hence we get x square y2 plus x y1 plus y equal to 0. Please practice this. Very important question. Move on to the next one. Another important question. Given y equal to, according to the question, given y is equal to a into e power mx plus b into e power nx. This is important for CET also. You should remember this as a result. If y is equal to a into e power mx plus b into e power nx, what is the answer? We get d square y by dx square minus m plus n into dy by dx plus mn y equal to 0. That part you should remember, okay, as a result. So we shall differentiate this with respect to x. We get dy by dx. dy by dx is equal to constant into variable. Here you should understand that a, b, m, n all are constants. Constant into variable. Constant keep as it is. Derivative of e power mx. E power mx into derivative of mx, that is m. Further differentiate mx. Constant into variable. Constant write as it is. Derivative of e power mx. E power mx into derivative of mx, that is m. Plus constant into variable. Constant keep as it is. Derivative of e power nx. E power nx into derivative of nx, that is n. Okay. Constant into variable. Constant write as it is. Derivative of e power x is e power x, but e power nx is given. E power nx into derivative of nx, n into 1. Again, differentiating nx means it is constant into variable. N is constant, keep as it is. Derivative of x1. So n into 1 is n. So I can rewrite this as, this is equal to a m e power mx plus b n e power nx. Correct? Same thing I wrote in the proper form. I wrote the constants first, am into e power mx. Bn is constant first, then write e power nx. Hope it's understandable. First constant into variable. Constant write as it is. Derivative of e power mx is e power mx into differentiation of mx. Derivative of mx is m into 1, m. Constant into variable. Constant write as it is. Derivative of e power nx. E power nx into derivative of nx, that is n into 1, n. So again differentiate. Differentiate with respect to x again. Differentiate with respect to x again on both sides. What I'm getting? We differentiate dy by dx, I get d square y by dx square. Correct? Here am is constant. Constant keep as it is. Am is constant. Constant into variable. Constant write as it is. Differentiate e power mx. Derivative of e power mx is e power mx into derivative of mx, that is m. So e power mx into derivative of mx, m. Constant keep as it is. Derivative of e power nx. E power nx into derivative of nx, n. Derivative of mx is m, m into 1, m. Derivative of nx, n into 1, n. Okay, because it is constant into variable. Constant keep as it is. N is constant, keep as it is. Derivative of x1. Derivative of x with respect to x1. So what I am getting here, second derivative as a m square e power mx plus b n square e power nx. A m square e power mx plus b n square e power nx. We got d square y by dx square like this. dy by dx is here. Consider this equation here. What is given? Left hand side to consider. So take LHS and prove that LHS becomes equal to RHS. Okay. LHS equal to what? d square y by dx square minus of m plus n dy by dx, m plus n dy by dx plus mn y, correct? This is equal to d square y by dx square minus m into dy by dx minus m dy by dx. I open the bracket. Minus m dy by dx. Minus into plus minus n into dy by dx plus mn into y. Now substitute for d square y by dx square from this. Substitute for dy by dx from this. Also substitute for y from this. All you substitute. Substitute for y dy by dx and d square y by dx square. All you have to substitute in this. So what I am getting? D square y by dx square, what I got? am square e power mx plus bn square e power nx. I substitute for d square y by dx square minus m into, substitute for dy by dx. dy by dx, what I got? am e power mx, am e power mx plus bn e power nx minus n into dy by dx, again substitute am e power mx plus bn e power nx plus mn into y. What is y? A into e power mx plus b into e power nx. Substitute for d square y by dx square minus m into, substitute for dy by dx from this minus n into, substitute for dy by dx from this plus mn into y is here, correct? Now simplify this. What we get? LHS I am simplifying, I should get equal to 0, that will be RHS. am square e power mx what I am getting here? A into m square e power mx plus bn square e power nx minus a into m square e power mx minus into plus minus bm n e power nx, correct? Minus into plus minus, yeah, minus am n e power mx minus into plus minus bn into n, bn square e power nx, yeah, plus am n e power mx plus bmn e power nx. I'll write the last term. There is no space. I'll write here. Plus, what is the last term here? bmn e power nx. bmn e power nx. Now see, all the terms will add up to 0. If I add all the terms, it will add up to 0. am square e power mx is cancelling. Cancelling means they are same terms with opposite sign. See, these two are cancelling. am square e power mx minus am square e power nx. They'll add up to 0, correct? Plus, minus. And bn square e power nx is here. bn square e power nx plus and minus. These two are cancelling, right? Minus amn e power mx plus amn e power mx. These two. And finally, these two. Finally, we get equal to 0 is equal to RHS. 5 marks. Very, very important. Please practice the problem. Okay, very important. Guaranteed question. Okay, 5 marks. On to the next one. Y equal to sin inverse x. Y equal to sin inverse x. Want to show that 1 minus x square into d square y by dx square minus x into dy by dx equal to 0. Given y equal to sin inverse x, given y is equal to sin inverse of x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What do you get? Derivative of sin inverse x. I'll use the symbol dy by dx for first derivative. Dy by dx equal to derivative of sin inverse x, 1 by root of 1 minus x square. Derivative of sin inverse x, 1 by root of 1 minus x square. Cross multiply this. What do you get? Root of 1 minus x square into dy by dx is equal to 1. Okay? Cross multiply. Derivative of sin inverse x we know. 1 by root of 1 minus x square. Cross multiply. We should do squaring on both sides. Squaring on both sides. This method is easier. Okay? Squaring on both sides. What do we get? Squaring on both sides. Root of 1 minus x square is 1 minus x square into dy by dx the whole square is equal to 1 square is 1. Squaring on both sides. Root of 1 minus x square is 1 minus x square. Dy by dx the whole square equal to 1 square is 1. Now differentiate this with respect to x on both sides. This equation we should differentiate with respect to x on both sides. Differentiate with respect to x again. Here you apply the product rule. First function keep as is. 1 minus x square. First function keep as it is. Differentiate dy by dx the whole square. 2 into dy by dx into derivative of dy by dx. D square y by dx square. Derivative of x square is 2x. Correct? Derivative of dy by dx the whole square is 2 into dy by dx. 2 into dy by dx into derivative of dy by dx is d square y by dx square. Correct? Applying product rule and also chain rule. Differentiate dy by dx whole square. As you differentiate x square, derivative of x square is 2x. So derivative of dy by dx whole square is 2 dy by dx into derivative of dy by dx d square y by dx square. Correct? Plus second function dy by dx the whole square. Second function keep as it is. Second function write as it is. Differentiate the first one. Derivative of 1 minus x square. Derivative of 1 0. Derivative of x square 2x. 0 minus 2x. That is minus 2x. And derivative of 1 is 0. Right hand side is 1. 1 is a constant. Derivative of constant is 0. First into derivative of second. First function write as it is. Differentiate dy by dx whole square. 2 dy by dx into derivative of dy by dx d square y by dx square. Plus second function keep as it is. Differentiate the first one. Now divide by 2 into dy by dx. Divide by 2 into dy by dx. Divide throughout by dy by dx. Divide throughout by 2 into dy by dx. Divide by 2 into dy by dx. So what do you get? Because 2 into dy by dx is common factor here. So I'm dividing this. So if you divide by 2 into dy by dx, we get 1 minus x square into d square y by dx square. I'm dividing by 2 into dy by dx. I'm dividing by 2 into dy by dx. Plus into minus is minus. Correct? Minus. 2 into dy by dx I'm dividing. So what I'm getting is x into dy by dx is equal to 0. Correct? Divide throughout by 2 into dy by dx. Plus into minus is minus. 2 into dy by dx cancels. X into dy by dx. Hence proved. Move on to the next one. Question number 5. Y is equal to sin inverse x the whole square. Show that 1 minus x square into second derivative minus x into dy by dx equal to 2 or minus 2 equal to 0. This equation also same type of the earlier one. Same as earlier one only. Given y equal to sin inverse x the whole square. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What do you get? dy by dx. Differentiate this sin inverse x the whole square as you differentiate x square. Derivative of x square is 2x. Likewise, differentiate sin inverse x the whole square by applying chain rule. Derivative of x square is 2x. So derivative of sin inverse x the whole square is 2 sin inverse x into derivative of sin inverse x, 1 by root of 1 minus x square. 2 into sin inverse x into derivative of sin inverse x, 1 by root of 1 minus x square. Derivative of x square is 2x. 2 sin inverse x into derivative of sin inverse x, 1 by root of 1 minus x square. Cross multiply this. Cross multiply. What do you get? Root of 1 minus x square into dy by dx. Cross multiply. Root of 1 minus x square into dy by dx is equal to 2 into sin inverse of x. Correct? By applying chain rule, I got this. Derivative of x square is 2x. 2 sin inverse x into derivative of sin inverse x, 1 by root of 1 minus x square. Cross multiply. Squaring on both sides. Divide, differentiate again with respect to x. Divide by 2 into dy by dx. Common steps. Differentiate with respect to x. Whenever they give inverse trigonometry functions, inverse trigonometry function is given to you. Normally, I will tell the steps. That too, sin inverse and cos inverse. In particular, whenever it contains sin inverse and cos inverse, the steps to be followed to form the second order differential equation. Okay, differentiate with respect to x, cross multiply, do squaring on both sides, differentiate with respect to x, and divide the entire equation by 2 into dy by dx. You'll get the answer. These are the steps to be followed. Squaring on both sides. Squaring on both sides. Squaring on both sides. What I get? If you square this, I get 1 minus x square into dy by dx the whole square. Dy by dx the whole square is equal to 2 square is 4 into sin inverse x the whole square. Squaring on both sides. And what is sin inverse x the whole square? According to the question y, substitute back. So this becomes equal to 4y. Because y is equal to sin inverse x the whole square. Y is equal to sin inverse x the whole square. Correct? 4 into y. Correct? Squaring on both sides. Root of 1 minus x square is 1 minus x square. dy by dx the whole square. Here 2 square is 4. Sin inverse of x the whole square is y. Squaring on both sides. Now differentiate with respect to x again. And divide the entire equation by 2 into dy by dx. Steps to be followed to form the second order differential equation when the given function is of the type y equal to sin inverse or y equal to cos inverse. Most of the time this is guaranteed. Okay, I can give 99% guarantee the steps to be followed whenever there is sin inverse and cos inverse, or sin inverse x the whole square, cos inverse x the whole square, or the questions can be of this type: sin of m cos inverse x or cos of m cos inverse x, like that. So differentiate, cross multiply, root will be there, cross multiply, do squaring on both sides, differentiate with respect to x again, and divide by 2 into dy by dx. These are the steps to be followed. Okay, now I am differentiating this with respect to x again. Differentiate with respect to x again. Differentiate with respect to x again on both sides. What do you get? Apply product rule. First function keep as it is. First function write as it is. Differentiate dy by dx the whole square. That is 2 dy by dx into derivative of dy by dx, d square y by dx square. 2 into dy by dx into derivative of dy by dx is d square y by dx square. Plus second function keep as it is, dy by dx the whole square. Second function keep as it is. Differentiate the first function. Derivative of 1 minus x square, that is minus 2x, is equal to, here 4 into y, constant into variable, constant keep as it is. Differentiate y with respect to x, dy by dx. At this stage, divide throughout by 2 into dy by dx. Divide throughout by 2 into dy by dx. Divide the entire equation by 2 into dy by dx. Correct? First function keep as it is. Differentiate dy by dx whole square. 2 dy by dx into derivative of dy by dx is d square y by dx square. Derivative of x square is 2x. 2 dy by dx into derivative of dy by dx is d square y by dx square. Plus second function keep as it is. Differentiate the first. Derivative of 1 minus x square is minus 2x. 4 into y. Constant into variable. Constant keep as it is. Differentiate dy by dx. When you divide by 2 into dy by dx, wherever 2 into dy by dx you cancel and write. Okay. So what we get? 1 minus x square into d square y by dx square. I am dividing by 2 into dy by dx. So this term I am not writing. I am dividing by 2 into dy by dx. Plus into minus is minus. 2 into dy by dx cancels. What do you get? X into dy by dx. Correct? Plus into minus is minus. 2 into dy by dx cancel out. Here I am dividing by 2 into dy by dx. So 4 by 2 will be 2. Correct? Dy by dx cancels because I am dividing by 2 into dy by dx. Or 2 you bring this side. Minus 2 equal to 0. From this, what do you get? 1 minus x square into d square y by dx square minus x into dy by dx minus 2 equal to 0. Correct? Dy by dx. Derivative of x square is 2x. 2 sin inverse x into derivative of sin inverse x. 1 by root of 1 minus x square. Cross multiply it. Then do squaring on both sides. And then differentiate. Also replace this back. Sin inverse of x the whole square is y. Okay. 4y. Differentiate with respect to x again. Apply product rule. First function write as it is. Differentiate dy by dx whole square. 2 dy by dx into derivative of dy by dx d square y by dx square. Plus second function keep as it is. Derivative of 1 minus x square is minus 2x. 4 into derivative of y is dy by dx. Divide the entire equation by 2 into dy by dx. 2 into dy by dx cancels out. 2 into dy by dx cancels. So plus into minus, minus x dy by dx. Divide by 2 into dy by dx and write. So we get the answer. Okay. Can add one slide and show you that whenever the questions of this type, I can give guarantee for these questions. Y equal to sin inverse of x. Y equal to sin inverse of x and y equal to cos inverse of x. These two, no? These two. Answer what we get is 1 minus x square into d square y by dx square minus x into dy by dx equal to 0. For these two. Answer what I am getting is this. And for these two, y equal to sin inverse x the whole square. Okay. And for y equal to cos inverse x the whole square. Y equal to sin inverse x the whole square and cos inverse x the whole square. For these two, what we have is 1 minus x square into d square y by dx square minus x into dy by dx minus 2 equal to 0 or equal to 2. For these two, answer I wrote. And for question of this type, y is equal to e power m cos inverse x and for y equal to e power m sin inverse x. For these two, answer is 1 minus x square into d square y by dx square minus x into dy by dx minus m square y equal to 0. For these two like this. Okay. And for these questions, y is equal to cos of m cos inverse x. Cos of m cos inverse x. Y equal to cos of m sin inverse x. Y is equal to sin of m cos inverse x. Y is equal to sin of m sin inverse x. In these four cases, answer what we get is 1 minus x square into second derivative d square y by dx square minus x into dy by dx plus m square y equal to 0. M square y is equal to 0. Okay. Otherwise, I will write it again. There's no space here. For these cases, I am getting the answer as 1 minus x square into d square y by dx square minus x into dy by dx minus x into dy by dx plus m square y equal to 0 minus x into dy by dx plus m square y is equal to 0. Okay, this is the equation. Cos of m cos inverse x, cos of m sin inverse x, or sin of m cos inverse x, or sin of m or sin inverse x. Last one, sorry, I wrote the same thing here. This is sin of m sin inverse x, sin of m sin inverse x. 4 different cases. Cos of m cos inverse x, cos of m cos inverse x, or cos of m sin inverse x, sin of m cos inverse x, or sin of m sin inverse x. In all these 4 cases, I get the answer as 1 minus x square into d square y by dx square minus x into dy by dx plus m square y equal to 0. Okay, that's the answer we get. And all these 2, 4, 5, 6, 7, 8, 9, 10. There are 10 questions here. There are 10 questions. 1, 2, 3, 4, 5, 6, correct? 7, 8, 9, 10. All these 10 problems can be done by the same steps. Differentiate, cross multiply, do squaring on both sides, differentiate with respect to x, again divide by 2 into dy by dx. Steps for these problems. Steps. Step 1. Differentiate with respect to x. Differentiate with respect to x on both sides. Whenever that root of 1 minus x square comes, no, cross multiply. Cross multiply, in particular root of 1 minus x square. Cross multiply root of 1 minus x square. Do squaring on both sides. Do squaring on both sides. If possible, replace that y by the given function. Okay, express in terms of y, right hand side. Squaring on both sides. Differentiate with respect to x again. Differentiate with respect to x again. Differentiate with respect to x again. And finally, you can divide by 2 into dy by dx. Divide by 2 into dy by dx. Divide throughout by 2 into dy by dx. You'll get the answer. Divide throughout by 2 into dy by dx. Alright. Divide throughout by 2 into dy by dx. Divide throughout. Divide throughout by 2 into dy by dx. These are the steps to be followed. Okay, steps to be followed for these kind of questions. Differentiate with respect to x, cross multiply that root of 1 minus x square, do squaring on both sides, differentiate with respect to x again, and divide by 2 into dy by dx. Divide throughout by 2 into dy by dx. All these 10 problems can be done by these steps. Follow these steps and work out. And can remember these results. Okay, it's very standard. It's better to remember all these things. It's almost same. See, everywhere you get 1 minus x square into second derivative minus x into first derivative, correct? That's common part everywhere. Everywhere you get 1 minus x square into second derivative minus x into first derivative you get. For these two, it is 0, equal to 0. For these two, equal to. For these two, equal to m square y. For these 4, equal to minus m square y. Over. That's it. Simple one. Next question, number 6 we have. This question is similar to the question which we had. This, not this type. This type of question. Okay. Where a and b, m and n are replaced by numbers 2 and 3 here. Given y is equal to, according to the question, given y is equal to 3 into e power 2x plus 2 into e power 3x. Differentiate with respect to x again. Differentiate with respect to x on both sides. Differentiate with respect to x. What do you get? dy by dx. Constant into variable. Constant keep as it is. Derivative of e power 2x. E power 2x into 2. Constant into variable. Constant keep as it is. Differentiate e power 2x. E power 2x into derivative of 2x, that is 2. Correct? Plus constant keep as it is. Derivative of e power 3x. E power 3x into derivative of 3x, 3. Constant into variable. Constant, right, as it is. Derivative of e power 2x. E power 2x into derivative of 2x, that is 2. Constant into variable. Constant, right, as it is. Derivative of e power 3x is e power 3x into derivative of 3x, that is 3. So 3 into 2 becomes 6 here. 6 e power 2x plus 2 into 3, 6 e power 3x. Differentiate with respect to x again on both sides. Differentiate with respect to x again on both sides. What we get? We differentiate dy by dx. D square y by dx square. Constant into variable. Constant keep as it is. Derivative of e power 2x. E power 2x into derivative of 2x, 2. Constant into variable. Constant keep as it is. Derivative of e power 3x is e power 3x into derivative of 3x, 3. Correct? Constant into variable. Constant, right, as it is. Derivative of e power 2x is e power 2x into derivative of 2x, 2. Constant into variable. Constant keep as it is. Derivative of e power 3x. E power 3x into derivative of 3x, 3. So what I am going to get? Here 6 into 2, 12 e power 2x plus 6 into 3, 18 e power 3x. Correct? 6 2s are 12. 6 3s are 18. Consider this equation now. Lx is equal to, consider Lx is d square y by dx square minus 5 into dy by dx plus 6 into y. Consider this and substitute 1 by 1. Everything will add up to 0. D square y by dx square we got like this. 12 into e power 2x plus 18 into e power 3x. This is d square y by dx square minus 5 into dy by dx is substitute. dy by dx is here. This is over. Come to this. dy by dx. 6 into e power 2x plus 6 into e power 3x. 6 into e power 2x plus 6 into e power 3x plus 6 into y is what? Y is here. 3 into e power 2x plus 2 into e power 3x. Simplify this. What do you get? 12 e power 2x into e power 2x plus 18 into e power 3x minus 5 into 6 minus 30 e power 2x minus 5 into 6 minus 30 e power 3x. 6 into 3, 18. 18 e power 2x. 6 into 2, 12 e power 3x. Correct? So what do we get? 12 e power 2x, 12 e power 2x plus 18 e power 2x, 30 e power 2x, 30 e power 2x minus 30 e power 2x will become 0. Correct? 12 plus 18, I'll write 30. 30 e power 2x. Here 18 plus 12, 30 e power 3x. Adding this and this, 30 e power 3x. Correct? And what is left is minus 30 e power 2x minus 30 e power 3x. 30 e power 2x minus 30 e power 2x. These two will cancel. These two will cancel. Will add up to 0 equal to RHS. Hence proved. Even this is quite important. Please practice this question. Okay. Move on to the next one. y equal to a cos x plus b sin x. A and b are constants, of course. Want to show that d square y by dx square plus y equal to 0. Given y equal to a cos x plus b sin x. Given y is equal to a cos x plus b sin x. Differentiate with respect to x. You get dy by dx. dy by dx equal to constant into variable. Constant keep as it is. Derivative cos x minus sin. Constant into derivative cos x minus sin x plus b into derivative of sin x is cos x. Correct? Constant into variable. Constant you write as it is. Derivative cos x minus sin x. b into derivative sin x is cos x. Again differentiate this. Differentiate with respect to x again on both sides. Differentiate with respect to x. Differentiate with respect to x again on both sides. What do you get? d square y by dx square. d square y by dx square is equal to minus a into derivative of sin x is cos x. Correct? Constant into derivative of cos x is minus sin x. Correct? Constant into variable. Constant keep as it is. Derivative of sin is cos. Minus a is constant kept as it is. Derivative of sin is cos. b into derivative cos x minus sin x. You can take minus a common here. Minus a is common. So what remains inside? Sorry, minus is common, not minus a. What a mistake. Not minus a. Minus is common. Minus is common. So minus means minus 1 is common. So what remains inside the bracket? A cos x plus b sin x. Correct? Minus sign is common. Terms inside the bracket is what? A cos x plus b sin x, because minus sign is taken out. That is nothing but y according to the given question. A cos x plus b sin x is y. Correct? So I am getting d square y by dx square equal to minus y. Therefore, d square y by dx square plus y equal to 0. Because I am getting d square y by dx square equal to minus y, shift it to other side. D square y by dx square plus y is equal to 0. Hence proved. Okay. Move on to the next one. Y is equal to 5 cos x minus 3 sin x. Prove that d square y by dx square plus y equal to 0. This is also similar to the earlier one. Given y is equal to 5 cos x minus 3 sin x. 5 cos x minus 3 sin x. Differentiate with respect to x on both sides. What do we get? dy by dx is equal to constant into variable. Constant keep as it is. Derivative of cos x is minus sin x. Minus 3 into derivative of sin x is cos x. Correct? Constant into variable. Constant keep as it is. Derivative of cos minus sin. Minus 3 is constant keep as it is. Derivative of sin x is cos x. So what I am getting here is minus 5 sin x minus 3 cos x. Differentiate this with respect to x again. Differentiate with respect to x again on both sides. Differentiate with respect to x again on both sides. What we get? D square y by dx square is equal to minus 5, constant keep as it is. Derivative of sin x is cos x. Constant keep as it is. Derivative of cos x minus sin x. Correct? You can take minus common. If you take minus sign common, what you get is 5 cos x minus 3 sin x. Correct? Because minus into minus is plus. I don't multiply. This minus you keep outside only. So what is left is 5 cos x minus 3 sin x. Terms inside the bracket is nothing but y. So this is equal to minus y. Correct? 5 cos x minus 3 sin x is y from the given equation. So d square y by dx square equal to minus 5. Therefore, what I get? D square y by dx square plus y equal to 0. Minus y, take that, so it becomes plus y equal to 0. Hence proved. Move on to the next one. Y is equal to 500 e power 7x plus 600 e power minus 10x. Show that d square y by dx square equal to 49y. Here, constant into variable form. Constant keep as it is. Differentiate the variable. Given y is equal to 500 into e power 7x plus 600 into e power minus 7x. Differentiate with respect to x on both sides. dy by dx. dy by dx is equal to 500 into derivative of e power 7x. e power 7x into derivative of 7x is 7. Constant into variable. Constant keep as it is. Derivative of e power 7x. e power 7x into 7. Plus 600 into derivative of e power minus 7x. e power minus 7x into derivative of minus 7x is minus 7. Correct? Constant into variable. Constant keep as it is. Derivative of e power 7x. e power 7x into derivative of 7x is 7. Constant into variable. Constant keep as it is. Derivative of e power minus 7x. e power minus 7x into derivative of minus 7x is minus 7. I don't multiply this big numbers, it becomes no. So I'll keep the constant term as it is. Constant is 500 into 7. 500 into 7, I don't multiply it, okay, keep as it is. 500 into 7 e power 7x. Plus into minus is minus. 600 into 7 e power minus 7x. Differentiate with respect to x again. Differentiate with respect to x again on both sides. Differentiate with respect to x again. What do you get? D square y by dx square is equal to constant keep as it is. Constant write as it is. Differentiate e power 7x. e power 7x into derivative of 7x is 7. e power 7x into derivative of 7x is 7. Constant into variable. Constant keep as it is. Derivative of e power minus 7x. e power minus 7x into derivative of minus 7x, that is minus 7. Correct? Constant keep as it is. Derivative of e power 7x. e power 7x into derivative of 7x is 7. Constant keep as it is. Derivative of e power minus 7x. e power minus 7x into derivative of minus 7x is minus 7. 7 into 7 is 49. Minus into minus is plus. Correct? Here also I get 49. So I get 49 common here. Correct? 7 into 7, 49. Minus into minus plus. 7 into 7 is 49. So 49 is taken out. What remains? 500 e power 7x plus 600 e power minus 7x. 500 e power 7x plus 600 e power minus 7x. Terms inside the bracket is y. Therefore, d square y by dx square is equal to 49y. Correct? Terms inside the bracket is y according to the question. 500 e power 7x plus 600 e power minus 7x is y. So this is 49y. d square y by dx square equal to 49y. It's a standard question for even competitive exams. They can ask question like this. Already I told y equal to a into e power mx plus b into e power minus mx. In that case, d square y by dx square equal to m square y. M is 7. See, m is 7. The power of exponential function is 7. 7 square is 49. Suppose I gave a question like this. Y is equal to 2025 e power 3x plus 2026 e power minus 3x. What is d square y by dx square? Here you observe that m is equal to 3. Correct? 3 square how much? 9. 9y over. No need to differentiate. Directly get the answer. A into e power mx plus b into e power minus mx. D square y by dx square is m square y over. Hope you understand this. Okay? 2025 e power 3x plus 2026 e power minus 3x. D square y by dx square is 9y because m is 3. 3 square 9 over. Move on to the next parametric form. Given equations are in this form. X equal to function of t, y equal to function of t. You know how to find dy by dx. dy by dt by dx by dt. dy by dt is g dash of t. dx by dt is f dash of t. For f dash of t not equal to 0. Then you are finding second order derivative d square y by dx square, which is d by dx of dy by dx, which is d by dt of dy by dx into dt by dx. By chain rule it follows. Okay, I'll work out the problems. Already one question was there in the miscellaneous exercise. Okay, finding the second order derivative for parametric function. Okay, parametric equations. That is done in miscellaneous exercise only. But here I've taken extra questions, which is not there in the NCERT book. I've taken few questions here. I've taken 3 questions, I think. There are 3 questions here, 1, 2 and 3. There are 3 questions which is not found exactly in the NCERT book. Of course, these parametric forms are found in NCERT book only. Exercise 5.6 it is present, but finding second order derivative for this is not given in the NCERT book. Okay, I am finding second order derivative for this. X equal to 80 square, y is equal to 280. These are the parametric equations of the parabola we know. X equal to 80 square, y is equal to 280. Parametric equations are given. Differentiate with respect to t because the parameter is t here. Dx by dt is equal to constant into variable. Constant keep as it is. Derivative of t square with respect to t, that is 2t. dy by dt. 2a is constant. Constant into variable. Constant keep as it is. Differentiate t with respect to t, 1. Constant into variable. Constant keep as derivative of t with respect to t is 1. Therefore, dy by dx. dy by dx. dy by dx is dy by dt by dx by dt. dy by dt by dx by dt. dy by dt is 2a. dx by dt is 2at. 2a cancels. We get 1 by t. Correct? dy by dx is dy by dt by dx by dt. Here constant into variable. Constant right as it is. A is a constant. Differentiate t square with respect to t, 2t. Constant into variable. Constant keep as it is. Derivative of t with respect to t1. dy by dt by dx by dt. dy by dt is 2a. 2a into 1 is 2a. dx by dt is 280. 2a cancels. 1 by t. We got dy by dx. Now find d square y by dx square. Therefore, d square y by dx square is equal to d square y by dx square is d by dx of dy by dx. d by dx of dy by dx. Correct? d by dx of what is dy by dx? We got 1 by t. dy by dx is 1 by t. Derivative of 1 by t with respect to x. Find derivative of 1 by t with respect to x. See, I am not differentiating 1 by t with respect to t. If you are differentiating 1 by t with respect to t, it is minus 1 by t square. I will write the steps if you want. See, what is, I will ask question, d by dx of 1 by x. What is d by dx of 1 by x? What is d by dt of 1 by t? What is, answer these 2 questions first, then you can answer this. Here the variables are same, no? Derivative of 1 by x with respect to x, how much? Minus 1 by x square. Derivative of 1 by x with respect to x is minus 1 by x square. Derivative of 1 by t with respect to t, minus 1 by t square, because variables are same. Here the variables are different. Derivative of 1 by t with respect to x, or derivative of 1 by t with respect to x, minus 1 by t square into dt by dx. Derivative of 1 by t is what? Minus 1 by t square into, further differentiate t with respect to x. By chain rule it follows dt by dx. Correct? Derivative of 1 by t with respect to x. Here the variables were same. I am differentiating 1 by x with respect to x, minus 1 by x square. Derivative of 1 by t with respect to t, minus 1 by t square. Correct? But here you are differentiating 1 by t with respect to x, which is minus 1 by t square into, further differentiate t with respect to x, dt by dx. And dt by dx is the reciprocal of dx by dt. dx by dt, how much we got? 280, no here? 280 dx by dt. dt by dx, you know that first derivatives are reciprocals. Suppose dx by dt is not equal to 0, dt by dx is 1 by dx by dt. So dx by dt and dt by dx are reciprocals. The first order derivatives are reciprocals, but second order derivatives are not reciprocals. I'll give more information about this and also get the relationship between d square y by dx square and d square x by dy square. I'll do the synopsis part of differential for KCT also. In detail, I'll do all the synopsis part with examples. Okay, I've done the PYQs of differentiation chapter from 1984 till 2025. Okay, all the questions covered of differentiation chapter. Now next I'll do the synopsis also of this, okay, in detail, because only studying PYQs we can't score out of 40. Our aim is to score out of 40, 60 out of 60, correct? To crack all the questions, that's our aim. So to crack all the questions in all competitive exams, you should study not only PYQs, even non-PYQ is also important. Which question has not appeared so far, that is also important. So in detail synopsis also will come shortly, okay, will be uploaded. dx by dt is 280, dt by dx is reciprocal of this 1 by 280. That will be 1 by 280. So minus 1 by t square into 1 by 280 is equal to minus 1 by 2at cube. So d square y by dx square is minus 1 by 2at cube. Understood, no? Derivative of 1 by x minus 1 by x square. Derivative of 1 by t with respect to t minus 1 by t square. Here you are differentiating 1 by t with respect to x. So differentiate 1 by t, derivative of 1 by t with respect to t you differentiate and multiply by dt by dx. That means you further differentiate t with respect to x. By chain rule it follows. dt by dx is reciprocal of this. dx by dt is 280, dt by dx is 1 by 280. Reciprocal of this is dt by dx. dx by dt reciprocal means ulta 1 by is correct. dt by dx 1 by 280 minus 1 divided by 2a t square into t is t cube. So minus 1 by 2a t cube. Next one, x equal to t square, y equal to t cube. Find d square y by dx square. Parametric form, second order. So dx by dt find out. dx by dt is equal to derivative of t square is 2t. Correct? Derivative of t square with respect to t, that is 2t. Derivative of t cube is 3t square. Derivative of t square 2t. Derivative of y with respect to t, that is derivative of t cube is 3t square. Correct? Therefore, dy by dx. dy by dx is equal to dy by dt by dx by dt. dy by dt by dx by dt. Correct? dy by dt we got 3t square. dx by dt we got 2t. So this becomes 3 by 2 into t. Correct? 1t got cancelled. Derivative of t square with respect to t is 2t. Derivative of t cube with respect to t 3t square. dy by dx is dy by dt by dx by dt. 3t square divided by 2t. 3t square by 2t. That becomes 3 by 2t. 1t will cancel. Therefore, now I can find d square y by dx square. d square y by dx square is d by dx of dy by dx. d by dx of dy by dx. d by dx of dy by dx we got how much? 3 by 2t. 3 by 2t. Constant into variable. Constant keep as it is. Constant keep as it is. Differentiate t with respect to x. That is dt by dx. dt by dx. That's equal to 3 by 2 into. Correct? dt by dx is reciprocal of this. dx by dt is 2t. So from this dt by dx is 1 by 2t. Reciprocal. Correct? dt by dx. The reciprocal of 2t is 1 by 2t. So dt by dx is 1 by 2t. That's equal to 3 by 4t. Okay. So dt by dx is the reciprocal of this. 2t reciprocal 1 by 2t. Correct? dy by dx. dy by dt by dx by dt. 1t got cancelled. 3 by 2 into t. So d square y by dx square. d by dx of dy by dx. dy by dx is 3 by 2t. Constant keep outside. Derivative of t with respect to dt by dx. dt by dx is 1 by 2t. So 1 by 2t. So 3 by 4t. That's the answer. Is that clear? dx by dt, dy by dt, then find dy by dx, dy by dx, dy by dt by dx by dt, 3 by 2t, constant into variable, constant keep outside, differentiate t with respect to x, dt by dx, which is reciprocal of this 1 by 2t. So 3 by 2 into 1 by 2t, which is 3 by 4t. The denominator is t. Hope it's clear. Move on to the next one. X equal to a into cos t plus log of tan t by 2, y equal to a sin t. dy by dx is tan t. It's a very standard question for 3 marks. But here I am asked to find the second order derivative. I shall do in detail all the steps. Okay. dx by dt first. dx by dt is equal to constant into variable. Constant keep as it is. Derivative of cos t is minus sin t. Derivative of log x is 1 by x. Derivative of log of tan t by 2 is 1 by tan t by 2 into derivative of tan t by 2 is secant square t by 2 into derivative of t by 2 is 1 by 2. Correct? Derivative of cos is minus sin plus derivative of log x is 1 by x. 1 by tan t by 2 into derivative of tan t by 2 is secant square t by 2 into derivative of t by 2 is 1 by 2. Correct? Derivative of log x 1 by x, but this is not x. So further differentiate, derivative of tan is secant square. Secant square t by 2 into derivative of t by 2 is 1 by 2. Correct? Now simplify this. A into minus sin t plus 1 by tan, you write sin by cos. Sin t by 2 divided by cos t by 2. Secant square is 1 by cos square. 1 by cos square t by 2 into derivative of, that is 1 by 2, keep as it is, I am not differentiating, I am simplifying it. Derivative of log of tan t by 2 is 1 by tan t by 2, derivative of tan t by 2 is secant square t by 2, derivative t by 2 is 1 by 2. Tan arrow sin by cos, secant square 1 by cos square, 1 cos will cancel, 1 cos remains, 1 by 2 sin t by 2 cos t by 2, which is sin t. Correct? What I am getting is A into minus sin t plus 1 by 2 sin t by 2 cos t by 2, 2 sin t by 2 cos t by 2, 2 sin t by 2 cos t by 2 is sin t. So A into minus sin t plus 1 by 2 sin t by 2 cos t by 2 is sin t. So that is equal to A into, take common denominator, sin t. Sin t by 1, correct? Minus sin t by 1. So minus sin square t plus 1 I get. Taking LCM and simplifying. And this is 1 minus sin square t. 1 minus sin square t is cos square t. So I am getting A into cos square t divided by sin t. Correct? Take LCM, sin t minus sin square t plus 1, which is 1 minus sin square t, cos square t. That is a dx by dt. dy by dt is A cos t. Derivative of A sin t is A cos t. Derivative of A sin t is A cos t. Now find dy by dx. Dy by dx is dy by dt by dx by dt. Dy by dt divided by dx by dt. Dy by dt is A cos t. Dx by dt is A cos square t by sin t. A cos square t divided by sin t. A cancels. 1 cos will cancel. Cos by sin cot. 1 by cot will be tan. Correct? This is 1 by cot t. 1 by cot t, which is tan t. This is dy by dx. Therefore, now find d square y by dx square. D square y by dx square is d by dx of dy by dx. D by dx of dy by dx, which is d by dx of dy by dx, we got tan t. Correct? So derivative of tan t, I am differentiating tan t with respect to x. Secant square t into further differentiate t with respect to x, dt by dx follows by chain rule. Secant square t into further differentiate t with respect to x, dt by dx, and dt by dx is reciprocal of dx by dt. So dx by dt we got like this, A cos square t by sin t. No, write the reciprocal of this, that will be dt by dx. So what I am getting is secant square t into dt by dx, reciprocal of this, sin t by A cos square t. Correct? Sin t divided by A cos square t. Like this we get. Reciprocal of dx by dt is dt by dx. Sin t goes to numerator, A cos square t for denominator. That means I can write 1 by A sin t, and secant square t denominator becomes cos square. Correct? So sin t divided by A into cos power 4t we can write. Or else we can take this to numerator. So I'll write the answer here. I'll write the answer here. Last step. D square y by dx square is equal to sin t, keep as it is only, sin t divided by a into secant square, take it to denominator, becomes cos square. Already there is one cos square into another cos square becomes cos power 4t, cos power 4t, sin t by a into cos power 4t. This is the answer. Finding d square y by dx square. Okay, sin t by a into cos power 4t is answer. Or else you can keep in different form also. Sin by cos tan you can write, tan t by a into cos cube t also you can write. Different ways you can write. So with this, we completed all the questions of NCERT exercise 5.7, finding second order derivatives. Many important questions were there for 5 marks, and some few additional questions I have taken it so that it is beneficial for you. Okay, because not only just studying NCERT, you have to go beyond NCERT. Slightly I gone outside NCERT book, some questions, not exactly so much outside, because within the NCERT only I have extended to find the second order derivatives. I have divided the second order derivatives for 4 types. First one is type 1 explicit form, type 2 is implicit form, and third one is formation of differential equation, and lastly I got parametric form. Okay, please all these things you study properly. Parametric form I have taken 3 questions, and so this was parametric form type 4. Okay, type 4 is parametric form. Type 3 I have given additional information also, finding the second order derivatives for these kind of functions. Okay, and one important result also I have told here for CET point of view. These kind of results are very much important. Okay, and the steps also to be followed to work out all these 10 problems. If you have time, please work out all these problems. Okay, and these kind of questions are found in NCERT exemplar book. Also I'll be solving NCERT exemplar book also completely. Okay, one by one, chapter wise I'll take and solve. Okay, these are the questions we did. 5, 4, 3, all these things very important questions, very important. This is a 5 marks question, very important. Please practice it. Okay, even this is important. Question number 2 is also important. Question number 1 is also important. Formation of differential equations, all these things very important question. Please practice it and also learn it as a standard results. Okay, time saving results for competitive exams. And we had questions on implicit form, form, that is finding the second order derivatives for implicit functions, and also type 1 we had. Okay, and type 1 was explicit form, where we had y is equal to a function of x. These 11 questions were the explicit form. All I have completed. Okay, second order derivatives, everything is completed. Second order derivatives 5.7 exercise is completely solved along with the solved examples, and also I given important techniques how to answer the question. Steps are also given to answer different type of questions, divided into 4 parts and done. Explicit form, implicit form, parametric form, and formation of differential equations. With this I'll conclude. Thank you.